Hey everyone, welcome to another deep dive. Today we have with us Jesse Eisenberg from dlc.link. Welcome, Jesse.
Thank you very much. Good to be here.
Yeah, so I guess the first question would be, how did you end up, what was sort of the problem that led you to building, what would you call it, like a Bitcoin to Ethereum bridge?
The start actually was rather interesting and probably not what would be normally considered good advice for starting a new project or founding a startup company, which was that we found a technology that we thought was interesting and set about trying to find a problem to solve with it. And I think usually you want to make businesses the other direction, right? Like solve a real need and, find a way to solve a need rather than force a technology into a need.
Sir, this is blockchain. This is...
Okay, right. Fair enough. Like, let's just invent cool stuff and find a way to use it. So there is a technology called DLC, discrete log contract. And I actually had met up with my co-founder here in Budapest. He's of Hungarian descent, but living in America. I'm American, born American, but now living in Budapest. So we actually met here in Budapest and had been talking about our mutual interest of crypto and blockchain and just general tech startups. And we're really keen on doing something in this space. And he was familiar with DLC technology, discrete log contract, which is a Bitcoin technology. It's kind of like a cryptographic process by which two parties can form a series of partial Bitcoin contracts, Bitcoin transactions, and only sign and kind of have like a zero knowledge signature on and a guaranteed signature on each other based on the outcome of an oracle. So based on an oracle, you would, I've kind of now jumped a little bit ahead into
we're going to get into this, hopefully.
We're going to get into it. Right. And so for now, I'll just say at a high level, it's kind of a way that two parties can use core Bitcoin technology to both partially sign something that the other will be able to use and close that. And it's kind of acting a bit like a smart contract. My app does that from time to time too. And based on the outcome of an oracle. And so we were excited about this technology, and right away we thought, well, Bitcoin just isn't smart like smart contract blockchains are smart, like ETH, like all the capabilities that you have on ETH and various EVM chains and all the other chains basically these days. So could we use DLCs to make Bitcoin more powerful? And one thing that was unique to us is that we weren't really in the maxi crowd exactly. We were both like staunch believers that Bitcoin is probably the best store of value in the blockchain space, but that it wasn't very usable, meaning like smart contracts. But maybe that's a good thing with Bitcoin. And boy, wouldn't it be great if we can find a way to use DLCs to make Bitcoin as programmatically powerful as ETH without giving up on the security model that Bitcoin has currently. So that was sort of like, hey, there's something on DLCs. Could we use that for this purpose? And that's how DLC Link got started.
Super cool. Well, yeah, you had kind of started, to get into what are DLCs. So, I mean, for those that haven't heard of DLCs, like, is this a new technology or has this been around for a long time?
It has been around a couple of years. I would say, I think about 4 years, give or take, was when the original DLC white paper dropped, maybe almost 5 years now, something like that. Oh, wow. And it's actually co-authored by Kaj Drykia of the co-creator of the Lightning Network. So somebody definitely with a lot of clout in the Bitcoin space. And it caught the attention of a lot of Bitcoiners out there because it looks like a slick way to make Bitcoin more powerful without relying on much external knowledge or pushing any new BIPs, upgrading the Bitcoin technology stack at all. It can work within the current technology limitations. And actually, that was before Taproot. It was built to work without Taproot, but it's more efficient and works better with Taproot and with Schnorr. But it could work even without it. And you know, from our perspective, one of the reasons, although this technology was around now for about 5 years, and a few people have tried to develop into it and build cool tools on it, but because it was a bit of an arcane Bitcoin tool, piece of knowledge, most of the people who knew about it and were willing to learn into it were very firmly in the Bitcoiner camp. And I think that limited, this was at least before the explosion of Bitcoin L2s, which is a very recent phenomenon. And so most of the building in DeFi was happening on the EVM chains or other chains. So most of the people who bothered to learn about DLCs weren't really interested in, say, Ethereum. And therefore, it kind of just lived as this niche knowledge inside of the Bitcoin ecosphere. We were pretty much the first, I think actually the first group that said, hey, let's use DLCs as a way to abstract interaction to Bitcoin and connect it immediately to Ethereum. Because like we can build software in Ethereum, smart contracts there, and let the outcomes of those smart contracts on Ethereum act as the oracle, which would feed data to Bitcoin, rather than relying on somebody who says, hey, I have an oracle, trust me. Let's make Ethereum the oracle and DLC the technology layer that would bridge that into your Bitcoin contracts.
Super cool. Yeah, I mean, we had because I mean, lots of people have been trying to put Bitcoin on Ethereum, right? Like you had like Ren BTC, you had WBTC, you know, TBTC is a different sort of model that's still around. You know, so like this isn't a new problem, but it seems like nobody's quite figured it out 100% yet, you know? And
yes.
So yeah.
I think we're a step, I like to think we're a step closer than anyone's gotten so far. We'll see if we've cracked the nut entirely, but we're a step in the right direction.
Cool. Well, yeah, so I did a little research on DLCs beforehand. So I'll try and draw it out and you let me know how it looks. So like I think like the way it works in Bitcoin, you have like, it's not a smart contract. It's like it's just a multi-sig for all intensive purposes, right? And then you would have like Alice, draw Alice with some hair, and she's gonna put in, say, like 2 Bitcoin here, okay? And I guess we'll just use one person, but multiple people can also deposit, right? Lots of people could deposit.
Definitely better to start with the simple case. There is a way to do a many party DLC, but the explosion of the number of signatures becomes more complicated later.
Okay.
But it would be doable. It would be doable.
And then what she'll do is she basically she signs like a transactions, right? She signs like say like she'll sign like send money to Alice or back to Alice, right? So this contract will be able to run this transaction that's in there. Correct?
Yes, so she kind of like is pre-signing.
She's like pre-signing this transaction
outcomes that she would agree to, that she wants to see happen. Yeah.
So like we could have like she could sign like send money to Alice, or she'll say like send money to Bob, and Bob's over here, who maybe is happy or not happy. And then, but she sets an oracle, right? So set oracle. And then the oracle it's different than an oracle on Ethereum, right? Because it's basically just an address. Can it be a set of addresses? I think it can be, right?
It is in fact, the oracle here, the DLC oracle on Bitcoin, it's really just a piece of data. It's a data provider that is going to sign that data with its Bitcoin key. So actually, there's not really an address or a wallet per se for the Oracle. It's purely going to say like, hey, at some point in the future, I will attest to the outcome of the football match, and I will sign it with this key. And the possible outcomes are, you know, the Patriots win or the Niners win, or there's a
Right.
tie. So it sets the initial set ahead of time, and it's like, this is the key that I'll use. And then at some point in the future, it's going to pick one of those and sign it with the key.
Well, you would have to pick the person's key while you're setting up the contract, right?
Alice and Bob need to know that Oracle's key. That they actually have to have included the three possible future outcomes, one of which the Oracle will choose. They will take those three ahead of time and use those as
so there's always three
here.
There's always three?
No, three is just a hypothetical, but like Alice and Bob will, however many outcomes the Oracle will produce, potentially, like however many outcomes it will choose from, Alice and Bob will sign as many possible outcomes that match what the Oracle may eventually sign from.
So like in this example, we could say like, you know, like did the Patriots or I don't know, did the Patriots or the Steelers win? And so like he can say like, so like did the Patriots win, I guess would be. So like he can either sign like yes, no, or invalid. Right? Like the game got canceled. And right. So
sure.
You know, so like these would be sort of the three outcomes, and you would basically set his address, and then after the game, at some point, he'll come back in here and sign one of these three, and at that point, based upon these outcomes, it's either going to run one of these transactions that we had.
That's right. Yes. Yeah. Yeah, what would happen is when the Oracle signs one of those three possible outcomes, that signed outcome will be now published publicly, available to the whole world. In fact, the Oracle, one of the cool things about this is the Oracle doesn't actually know who Alice and Bob are. The Oracle doesn't know if anybody is or is not actually betting or creating contracts based on the Oracle's output. The Oracle's kind of totally
he could see that. I mean, right? Like it's not like it's not private necessarily, or is it? Could you make it private?
The Oracle is producing data publicly, but what Alice and Bob do is inherently private. Like they could probably go out of their way to tell the Oracle something, right. but no. Yeah, in fact, what Alice and Bob do naturally would be completely private to just Alice and Bob. And the reason is because these transactions, these possible future outcomes, get wrapped up using technology. Actually, I think at this point, those outcomes were in fact using Schnorr signatures. So even if Bitcoin didn't have Taproot yet, which uses Schnorr, but prior to that, what Alice and Bob are signing just to keep among themselves was using Schnorr. And so, which is slick because they can just kind of sign and aggregate a bunch of keys. And then they keep these possible future transactions. They were referred to in the DLC white papers as CETs, contract execution transactions. And so they'll actually hold on to those themselves, and they don't go on chain, and nobody sees them. And when the Oracle chooses and signs one of the outcomes and publishes it publicly, they could put it on their Twitter, they could post it to a website, doesn't matter, it's a public thing. Either Alice or Bob has to go grab that public data and can use that to finalize one of those transactions. That one winning transaction goes on chain. And in fact, it looks just like Alice sent Bob money or Bob sent Alice money. It does not, in fact, look like any sort of contract was made there. So anyone observing on chain would see that money moved from one party to the other, but wouldn't know why, wouldn't know there was a bet, wouldn't know what kind of details they had on that contract.
So this whole thing, they would set this up and they would do these signatures, but that's all off chain that they're storing this. Oh, cool. Okay.
Yeah.
So, okay. And then and then they would pass it over. Yeah, and then obviously this is just the most basic DLC contract. But the question is like, how can we use it on Ethereum? We want to bridge it over, which is like a whole.
That took a while actually. We went through quite a few iterations to figure out what would work best. In fact, when we got started, we were trying to figure out, well, how can we basically represent the outcomes of an ETH contract in this DLC? And we weren't even really thinking about wrapping a token and making a wrapped Bitcoin token on ETH at that point. We were sort of really just saying, Alice will lock some token, Bob will lock some token. Or really, we started even thinking, well, Alice is a user and Bob is some kind of DeFi protocol. Maybe it's even like Aave or Curve Pool or somewhere you can kind of DeFi your money. And Curve has a smart contract on ETH. So let's say Alice locks 1 Bitcoin and she wants to put that Bitcoin into a Curve pool somehow, but without ever wrapping to ETH or something. Let's say that Alice just kind of locks that Bitcoin up in the DLC against Curve. Curve would need some kind of Bitcoin wallet representation, but if they had that, then we could say that based on the outcome of some smart contract on ETH, the Bitcoin locked in the DLC, which was entirely Alice's in this scenario, generally, if one of them's a DeFi protocol and one of them's Alice, it would either all go back to Alice or partly go back to Alice, or none of it would, depending on how, if she got liquidated in her position, or if there was some interest paid, probably that would be paid in an ETH token. Yeah.
Yeah. So like the basic way would be like, like if this was kind of like you were talking about, like this could be like the Aave DAO contract that has a representation over on Bitcoin. She would lock the money and it would get sent over basically the smart contract over here. So I guess we'll draw another smart contract down here on Ethereum. It would see the transaction from here and it would mint, I guess, some synthetic that would be placed into Aave. So kind of like, this would be like wrapped Bitcoin. So like, wrapped Bitcoin, usually the person that's saying mint is BitGo, the custodian for WBTC, but you could theoretically use any Oracle network over on ETH to say, okay, mint something synthetic that we're going to then lock into Aave, lock in Aave, and then after some time, this Oracle would then be able to say, okay, she's requesting a withdrawal, release it back to her, and whatever, give her her gains, or send to the Aave DAO because she got liquidated, something like that.
Exactly. Yes, precisely. Yes, it is very, we were imagining that as well. Like, maybe Aave doesn't really want to go through all the, that's actually the next step in our evolution is, well, okay, Aave doesn't really want to set up a Bitcoin wallet, and Aave doesn't really want to create some new synthetic type that they're going to support. So how do we start making this more generic, more and more generic? Okay, well, it's got to be an ERC20, not a 721, not some new and synthetic we're inventing. Like, how do we make it as simple as possible? So we kept stepping our way closer and closer to just a wrapped token.
Right. So you would set it here and then it would mint. I guess the questions that come to mind, the bigger thing is, I guess, who did you guys decide to be the other party in this contract? They run away. And then how do these oracles work?
Great question. Great question. Yeah. Right. So who is Bob in this case? And another problem starts coming up as well, that, if you're going to mint a token or mint some synthetic, if the synthetic is fully owned by it, so if Curve has the other Bitcoin wallet, so if Curve is Bob and the synthetic you mint is controlled by Curve and has to be controlled by Curve, then at least you're kind of, that could kind of make sense, because if the Bitcoin goes to to Curve's Bitcoin wallet, then in theory, that's supporting the price of that synthetic that it kind of matches against. We started to run into problems as we thought of how to make this more abstract, which is that, like a standard a 721 or this synthetic, I mean, if it's an ERC20, a 721, whatever it is, it's very common that those get transferred around. They could go into the pool, get mixed up, who knows where it's going to get, or somebody trades it with somebody else. And if you go back to the DLC, there's Alice and there's Bob. There's no Charlie. There's no other person that if they're holding this token, they can get the Bitcoin in the end that represents. So like a bridge normally has this concept that whoever is holding the Wraps token can burn it and get the Bitcoin representation of it. So that also, so those both became problems. The immediate the answer to yours, your question that you posed, was that in theory it would be Curve would have to hold the Bitcoin wallet, and we did not have any luck convincing DeFi protocols at all to like, hey, don't you've got this cool ETH, ETH is great, like don't you want to create a Bitcoin wallet and support this network and maintain this other synthetic, and then it can go into your Curve pools and be this whole new thing where Bitcoin is. We're creating more liquidity via Bitcoin, and that was just so many no's across the board. There's a couple of very Bitcoin friendly, like Bitcoin forward developers who were into it, and we actually got a lot of support from the Stacks community in the beginning, because actually it's not surprising, they support a lot of Bitcoin development projects.
Did you make proposals in the DAO forums?
Actually, I mean, we didn't in Curve. I think we did in maybe we did submit one at one point in Curve, like, hey, support Wrapped Bitcoin tokens or something like that. We didn't have any luck. So we set about thinking like, how can we make this token more abstract and actually solve some of these problems? And so we landed. So if it's okay, maybe I'll tell you a little bit more about the solution that we finally came up with.
Yeah, please.
So where we landed is that we still have the blockchain acting as the oracle. So some smart contract on a blockchain is acting as the oracle to the DLC.
So this would be like Teller or Chainlink or someone like that could.
Yes, absolutely. Really, it's actually quite open. Actually, as of right now, for our Wrapped Bitcoin, it's our own. It's the token contract of the Wrapped Bitcoin. It's the one that's and basically it just, when you open the DLC, it mints for you. When you burn the token, it closes the DLC.
Well, I mean, how can you? Well, I guess because like you said, this is all off chain. How does the Oracle know that you created? If you're not posting, because like theoretically, like if it was a Bitcoin transaction, you could use like a Bitcoin-like client on chain, like a BTC relay style thing. But this is all off chain, so like, do you guys have to store that data?
So how we end up, kind of. So what we have is, so where you have Bob in this. So the security model of a DLC is that Alice doesn't really need to trust Bob, and Bob doesn't really need to trust Alice. But they both have like a ZK guarantee of what each other one's doing, so they can say, like, I see that you've signed certain things. I don't have to trust you. You've provided these partial signatures to me that when the Oracle produces an answer, I can use that to exit the position.
So you're using like a ZK proof on Ethereum?
Not exactly, but I think it just follows a similar model, that there's no. Well, maybe I guess maybe it would be incorrect to say it's zero knowledge exactly. It's just it's just a series of proofs. It's just that Bob holds the proofs that, and in fact the partial signatures of Alice, and Alice holds the partial signatures of Bob's. Yeah, better to just say it that way.
You should talk. I had the succinct people. They're doing ZK bridges. You should go talk to them. They'll write you up something quick.
That would actually be very cool. There probably would be some optimization in there somewhere. So the trust model is that Alice and Bob each have data from each other, but they don't necessarily have to trust each other. They're both relying on the output of an oracle. And which, by the way, if the oracle was malicious and said that the Patriots didn't win when they did, that's the problem.
Yeah.
But DLCs do support a multi-oracle system, so you could have like a 2 of 3 or a 3 of 5. So they have to agree in a threshold in order to exit the DLC. But so anyway, the solution the solution we were able to come up with eventually is that we took Bob and made Bob a set of decentralized applications. So imagine 7 Bobs that are all running the same software and who have a shared or who operate each has one signature of a multi-sig on the ETH side that can actually take action on that synthetic.
Okay, so this is so it would be like a multi-sig over here on Ethereum. This is I'm guessing do you call it like the dlc.link wallet, or?
It's our dlc.link attestation network. These are we call Bob an attester. Yep. And they do have a shared wallet, exactly. So they have both. They have a threshold key wallet on the Bitcoin side and a multi-sig on the ETH side. And those actually, those are similar things done in a different way, right? Like each of those 7 participants has 1/7 of an aggregated key. So it's like with Schnorr, you can do this key aggregation thing. So there's one key and they each have, you could imagine like a 1/7 of that key, and you need 5 parts to form the key.
Okay. So it's kind of like a 5 of 7 multi-sig in a way.
It functions just like that. Okay. Yes, exactly right. With Schnorr, it's actually key aggregation. So you can add 5 keys together. Any 5 keys in this can give you the group key that you're looking for. So now Bob in the DLC is this group key of, you need 5 of those 7 Bobs to create the other end of the DLC in that DLC multi-sig. So Alice and the attester network. And if Bob looks closely at the DLC Alice's end of the DLC that she created and signed, and says, yeah, okay, you did this properly. And then if the threshold of Bob nodes, the attesters see that went well, they will go ahead and say, okay, we trust that Alice is going into the DLC properly. So therefore, and at this point that could be representing Curve or whoever controls something on the ETH side. So for now, for starters, it's our own token contract, our version of a wrapped Bitcoin, DLC BTC. So when a threshold of the nodes thinks that Alice entered the DLC properly, they go ahead and use their ETH keys to sign a multi-sig on that end and issue some ERC20 token.
So these are the guys that do the mint over here. The attestation network, who's right. Bob, is the same. It's the same 7 people.
Same 7. Yep.
Right. And then, are they staked? Do they have skin in the game? How did we pick these 7?
Great question. That is actually stepping into the tokenomics side of the world, but it is also very interesting. And I think we're going to follow in the footsteps of many of the great teams and organizations that have broke ground before us. We will be soon issuing a token of our own, which will be used to secure the network, the attesters. So those 7 are actually currently very hand-picked, well-respected node operators in the industry. So many of them currently have been running Chainlink nodes for years, or have node farms of many different blockchain nodes, and they're very well respected in the communities. And they will be staking the DLC token, as well as allowing your average person who wants to participate in the security of the network to delegate token to them as well. So that you're kind of standard like proof of stake sort of thing for not proof of stake for voting, because we want to keep this same like 5 of 7 threshold, or we actually might increase that to something like 10 of 15 at some point in the future. But each node does have a reputation score, and if it's not behaving well, if it's not signing with good performance, or if it's like actually signing incorrect messages or trying to grief the network, the performance drops and they can get slashed, and the delegators can get slashed as well. And meanwhile, they're earning a percentage of the bridge fees while they're acting well. So that's kind of what will support the token.
Nice. Yeah, no, cool. I guess, and will this be on Ethereum mainnet? I guess the staking and delegation.
It's a good question. We actually are currently running on Arbitrum as our first bridged network, especially after the recent upgrade. I forget the name. The recent ETH upgrade. Fees on the L2s have become just incredibly cheap, and we feel pretty good about running the bridge against an L2 now, and just knowing that everything that happens is happening with like negligible fee. We probably, we are the various tokens that we have, like the wrapped Bitcoin and this DLC token, can be bridged around, of course, to all the to ETH chains and even to non-ETH chains in the future, non-EVM chains. But we might actually make a bridge directly to L1 as well, and kind of have, you can choose whether you want to delegate directly in L1 or on Arbitrum L2, or do you want to bridge your Bitcoin directly to L1 or Arbitrum L2? And we're still kind of in the wait and see on that. There seems to be, well, fees are the advantage of the L2, but certainly a lot of people want to go directly to an L1 and never leave that. And that's also where a lot of the DeFi liquidity is, so it can make sense.
Right.
Good question.
Well, I mean, I was just thinking you have like a little DPoS network over here. Like, you could just be your own chain, man. This could be, I'll make a Cosmos chain. This would be awesome.
Actually, maybe. Yeah. Can you lead that project for us? We just need a little more engineering brain over here, and then we can pull it off. Maybe at some point in the future. Yeah.
Yeah. And then I guess the one thing we haven't talked about too is, who is this guy over here, the Oracle?
Yes, right. Well, so kind of actually. So we imagine, the Oracle, it always made sense to me. I mean, it never for a minute made sense to me, like it did with the Bitcoiners, that DLCs would require an Oracle. So the magic of the DLC is that Alice and Bob don't need to trust each other in order to set up a contract ahead of time and have the contract fulfilled. They need to trust an Oracle, who's like a mediator. Or if they don't trust only one Oracle, they use a set of Oracles. But I'm always thinking, like, okay, you don't trust Bob. You don't trust, maybe you think Bob is your adversary if you're Alice or something, but now you trust in the Oracle, right? And you run into the Oracle problem. And maybe it's just Bitcoiners haven't spent enough time to realize that there's such a thing as the Oracle problem. So to me, it always made sense, like, hey, because I already actually started on the ETH side, didn't really start on the Bitcoin side as far as development went, at least. And I thought ETH is the Oracle. Maybe you're a Bitcoiner. You trust Bitcoin as the best store of value. You want to keep your net worth in Bitcoin. Great. But what Oracle do you trust more than ETH? Do you trust just some dude with an API, or do you right. Why would I trust something to be the Oracle? Why wouldn't I just at least trust ETH, even if you don't think it's as good as Bitcoin? It's probably good enough to be your Oracle for Bitcoin contracts until Bitcoin has its own data sources. But so anyway, so an ETH smart contract, right? So you mint the smart the wrapped token on ETH, and when Alice burns the token on ETH, then the same set of attesters pick up that event. And if a threshold of them say, yep, Alice burned the token, we can go ahead and release the Bitcoin out of the DLC. They now they're acting as the Oracle. So they're going to
so these guys would be the Oracle as well. So
yep, on the Bitcoin side there. So that, it's like they're the Oracle. That's right. And they're pulling the data source that the Oracle uses is the ETH smart chain.
Yeah, no, I mean, I was going to say that because there's no need. since these guys are already the ones doing the minting over here, you already have a trust assumption there, so definitely don't add another one.
That's right.
So yeah, that works. Cool. And they would just, yeah, no, I think that works. Yeah, the question would just be, I guess, kind of like you were talking, how do you sort of decentralize the attestation network, make sure that, you know, it's not just a handful of people controlling everyone's Bitcoin over here.
That's right. That's right. Yeah. So we need to make sure that those are very reputable people. They're all different node operators. So like no single entity could ever get a hold of more than 1/7 or one piece of the threshold key. We hope we will increase that number in the near future. We're just kind of starting with 7 to get going. Yeah, we used to call that was kind of a big breakthrough on our end. We wanted to figure out a way to make a decentralized Bob, as we always used to say. But that it just conceptually, there were so many, you know, like I can look back at the last 2 years of work and say like, boy, I could have just done this in a month if I had known what I was supposed to do. But there were so many learnings along the way that we just had to pay the price and talk to the right people to redesign things in such a way. So where we ended up really is with, you know, this decentralized bridge, you can call it, but unlike other decentralized bridges, and I could call out Threshold Bridge a little bit because it's actually a great piece of technology, but I think we have one advantage over them, which is that, you know, in that case, you do send your money to the bridge. The bridge has the keys to the castle, but it's very decentralized. But in theory, bad software or who knows what could cause the bridge, which controls your Bitcoin, to do something nefarious with it. It could lose it or steal it or it could get hacked and sent to a hacker. And then, you know, in theory, the synthetic, wrap token will lose its value because the Bitcoin collateral supporting it is gone.
Because
this is really a DLC.
I guess the difference with Threshold, that they have a similar setup as far as an attestation network, but they just send it to a multi-sig, correct? Or a normal one, and then and then they mint it over. Yeah.
Yes, that's right. Yeah, I think they're also doing something on the Bitcoin side that's probably not like a proper multi-sig, but a threshold key, I think, hence the name. But it's functionally the same. Everybody has 1/7 of the vote or whatever, and when you hit a threshold, you're able to move the Bitcoin. And the thing is, just Alice sent that decentralized network her Bitcoin and said, "Here, please don't lose this. I guess you won't because you're very decentralized." Whereas in our case, Alice doesn't actually send any control to Bob because we're, you know, at the bottom layer, we're based on this DLC where Alice and Bob do not have to trust each other. Alice does not send the money to Bob and say, "Bob, please don't lose this." They've created this set of possible spending conditions. And so in this case, you know, we didn't really talk about it in your example. The Patriots win the Super Bowl or they don't. And those are the possible outcomes Alice has pre-signed. But in our case, the only outcome Alice pre-signed is give me my money back. At some point in the future, I want my money back. That's the only option. So if our network were to get compromised in some way, the network still wouldn't be able to take the Bitcoin or send it to a hacker or destroy it or something like that. They would potentially, when our network is acting as the oracle, they might just fail to sign the outcome and Alice won't get her money back, but which would be bad, but it wouldn't get lost. So after a matter of time, we could push a software update to save it, but it absolutely couldn't get stolen because
I mean, for Alice, you said
not within the possible outcome set for the oracle to sign.
Yeah, I mean, well, you said this is off chain, but Alex still sends a UTXO to this address, correct?
That's true. Yes. So yes, and that happens in a DLC, standard DLC, right? So the Bitcoin does get locked. We're calling that a self-custodial multi-sig or something like that. It does look like a multi-sig on chain, but unless Alice later chooses to say, yeah, I give up my right to participate in this multi-sig here, take my key. All that Alice has really done is provided those CETs, those contract execution transactions, those pre-partially signed outcomes. So she will sign one that says, give me my money back. She will hand that to the attester network. All 7 of those nodes will get a copy of it. And then she will lock her Bitcoin, the collateral, into the multi-sig. So in the future, when she burns the ERC20 token, the network will say, okay, Alice burned this ERC20 token. Therefore, we can sign something. If we all agree, let's sign something and act on one of the outcomes that Alice gave. The only outcome they have available to sign is the one Alice provided them, which is give me all my money back. So that's the only signature they can make. If they were to make, they couldn't make a different one because it's in a 2 of 2 with Alice the SIG, and she didn't provide a SIG for any other outcome. And if they just didn't do anything, then the money would be stuck. But the
which is good in some ways because you're not going to try and hack it.
You're not going to try and hack it.
Right.
Like, worst thing you could do is piss off Alice, but it's just there's not a lot of incentive. And as long as everything was set up properly, it's just a matter of time until we push a software update that unlocks it. So as long as both those keys, the group attester key and Alice key both still exist, eventually we will unlock this Bitcoin with a software fix. So so it makes the point of hacking the bridge very bad. In fact, the attack model now gets harder, a level harder than any other bridge, in that you have to both hack Alice and the bridge at the same time in order to have a chance to, like, okay, let me pay Alice back, but I've already hacked Alice, so now I can steal Alice's money. And well, if you've already hacked Alice's wallet, Alice has bigger problems than her bridged asset.
Right. Yeah. I mean, you should go partner with some data availability network, right? To post all the signed messages to. You could just say, like, oh, Celestia, here you go. Now you're involved in a Bitcoin bridge.
Yeah. We were thinking about, like, you mean for storing the possible outcomes there? Yeah, we were thinking, right, like, does IPFS make sense, or something decentralized storage system?
It sounds a lot like a data availability piece. To me, and so it's very interesting because like the obvious answer, if you were using ETH, you could, like, store these as blobs on Ethereum, and then just call it a day. So
yeah, in fact, there's nothing that you could compromise privacy a little bit, maybe, depending on how, if we were to encrypt them or something, there maybe not. But actually, there's nothing really dangerous about losing those anyway. You couldn't do anything with them. You couldn't, actually hack anything or steal anything. You would just learn a little bit.
Yeah,
exactly. People would see, oh, Alice put some money in the bridge. But to be honest, I don't think we're not really keeping that secret currently anyway.
Right. And I mean, how would Alice signal, I guess, what her ETH address is? Or does she have to just, like, message you guys?
Yeah, she kind of provides that. Yeah, that's right. Okay. She provides that ahead of time. And so right now our bridge looks like you authenticate with some EVM wallet. So we find out your ETH address. Okay. Then you set things up, you pay the Bitcoin, and then, 6 confirmations later, you get your wrap token.
Super cool. Yeah, and then I guess, like, the bigger question would be, how do you guys see this scaling? So, like, if you launch a token and you have staking and delegation, the big question with all of this, whether it's, this is a big problem for oracles, and people like to assume, listen, your market cap's only 300 million, but people have $1 billion worth of Bitcoin locked in the bridge. What do you do? Or should the market cap go up? Like, I don't know.
Well, we've got, Well, wrapped tokens also have a little bit of a simpler dynamic, but we're going to be combining that with our own sort of utility token, which is used for staking and slashing and stuff. So you would want to see that have a pretty substantial amount relative to the value of the token in the bridge, so that it feels like a good disincentive to act negatively, to act badly. But I would also say that, yeah, like the same way hackers couldn't hack the bridge, any of these 7 nodes, and do anything useful with it except kind of grief the network. Node operators couldn't collude and do anything bad either, right? So
you're just allowing Alice to get her money back, basically.
That's the only signature.
So like you don't
Alice
even send money.
System.
So you can't even send the money to the attestation network necessarily. You can just send it back to Alice.
All 7 testers could get together and try to hack things, and they wouldn't be able to.
Okay.
Yeah. Okay. So one weird thing that comes out of that is that, like, what we don't have is, if there's some, and so actually this is also why a little bit we started moving away from so DLCs can provide much more complex transactions other than just this one, hey, I'll lock it and you pay one outcome DLC, right? It's like the simplest possible DLC. But we just found that actually at first is the most useful way, like create a wrapped token, because once you have a wrapped token on ETH, do whatever you want with it, like put it into Aave. It's actually all of the ETH is just set up free to use in ERC20. They don't need anything more complicated than that. So that's the most powerful form of a token, of a tokenized asset. But if we wanted to interface with some, if like originally, like a year ago, we kind of had a DLC platform where any smart contract can act as the Bob, and we would have our network of Bob nodes doing the Bitcoin verification and doing the DLC stuff, and like register your smart contract with us, and we'll make you the kind of data feed for the Oracle system. But people inevitably wanted to have a system where they could either liquidate the asset. So if you do, if you make a loan in native Bitcoin, that was our pitch, like allow native Bitcoin collateral in your protocol. So Alice would lock 1 Bitcoin natively and take out a loan against it in your protocol on ETH, as if you have a Bitcoin of collateral. But then you do need a lot of possible outcomes to the DLC. And how many are you going to pre-sign, right? Like, what if if she gets liquidated 50% on the Bitcoin, you should have an outcome that's like maybe 50% or all of it goes back to Alice, or some kind of linear payout curve with what kind of fine granularity do you want to have there? Like, every, if you do 100 outcomes, then every 1%, you got to round it off and say Alice gets back 0.98 of the Bitcoin, but we don't have anything more accurate than 0.98 versus 0.99, nothing in between. And then people would also ask, well, what if like Charlie buys the liquidated asset directly? The money should really go to Charlie. And I would say, well, Charlie's not in the DLC. We can't send the money to Charlie. It's only Alice and Bob. So everything we tried to do with DLCs was too clever to really make the bridge function in a simple way that made sense for the ETH DeFi developers. And in the end, just a one outcome DLC for wrapping token was like, okay, it almost seems too simple after all the work we had done. But when I sit back and look at it now, it seems exactly right. We've taken a decentralized threshold bridge. We've put DLC on top of it so that you don't even have to trust the bridge at all. Even a fully hacked bridge couldn't steal your Bitcoin. And then just issue the wrapped token representing it.
The bigger question would be, like, I guess the way that you would hack it and steal it would be if a whole bunch of people take this wrapped Bitcoin token over here, and like, let's say there's a really liquid Uniswap, you would collude with Alice to then dump all of it for ETH, go put on Coinbase, and then go unlock your Bitcoin and split it, right? that would be the collusion.
That would work. So yeah, either any way you slice it, Alice would have to be involved in the attack, which means you can only kind of attack as much Bitcoin as you were participating, putting in collateral in the first place. But that's right. Like, we do have to be wary of the of the price of the token in the wrapped side. Like if you were to mess with the pools, and there can become arbitrages if you were to like crash the price on ETH and then get in really cheap and exit in a really profitable way. Something like that could happen. But we're working with kind of market makers and hoping to make sure we have a lot of liquidity on the bridge, such that if as little arbitrages happen, people will naturally jump in and say like, wow, like, DLC BTC is trading on like 0.98 on the Bitcoin. So I should wrap a bunch. Or actually, I guess it would work in the other direction. If DLC BTC is too cheap, people who have wrapped in the past, like these big market makers who are there purely to capture the arbitrage in order to keep the price steady, they would say, hey, like, oh, this token is starting to drop a little bit. I have a bunch of wrapped Bitcoin. Let me go ahead and snap that up and exit and get the arbitrage there. So I think market dynamics should handle the potential issue that the token price slides around.
I would just say like if Alice colludes with them and then you guys go dump on somebody who just takes, like if you're willing to trash the whole network and the reputation, like kind of like we were saying, if this is like 300 million, you have a bill locked up, then like if it was a bill with just one Alice, then you could theoretically like, or if you guys were Alice and we just didn't know, like that would be like the potential attack vector, I guess you could say. But
I see. Yeah. Well, if I had that much money, hopefully I'd have something better to do with it. But for
sure,
yeah. No, that's a good point. Yeah.
But I think it's okay. Like it's anytime you have, like with any of this stuff, that there's a little bit of a social contract piece involved and a little bit of a these guys will obviously have reputation that they'll want to uphold, hopefully, since they're people who have been delegated to. So yeah, I think until you get to crazy amounts of money, it's not it's not the biggest deal. This was anyway. What did I miss? I guess what can we add?
I mean, I think surprisingly, I think we really covered it all. Just to be clear, to be very thorough on the technology, right? So one thing that many bridges, so I think you can do this on TBTC, is that if you didn't have any Bitcoin to begin with, but you went on ETH, you bought some TBTC, you could unwrap it for Bitcoin. And in our case, you cannot do that unless you were there, unless you already have bridged in and entered into a DLC. Mm-hmm. You cannot be the person to exit the DLC. You can't get any Bitcoin because, again, there's Alice and Bob. There's no Charlie, and that's by design. We don't want there to be a possible way that someone other than Alice ever ends up with Alice's Bitcoin. So that limits a little bit.
Can anyone be Alice?
Well, also a good question. In the near future, we hope to open that up to, like, as we say, full retail. Anybody could be there. Anybody could be Alice. There's no technical reason why not. Right now, I think we just don't have the support team in place to just make sure that we can really scale up for that. So we're kind of onboarding more like market makers and merchants. So people who would want to wrap like 100 Bitcoin or more, something like that, just to get a lot of liquidity there that can act and do arbitrage to keep the price in a healthy way. And then we can kind of one off, like, handhold through the process for now. But the plus side of having, large amounts of liquidity on some of these contracts is that they will be there to keep the price steady and kind of buy it as needed or mint some more as needed as it becomes profitable for them, and that'll keep the price steady. So if I want to go on, if I never mint any Bitcoin, if I never use any Bitcoin to mint, but I'd rather just go use DLC BTC on ETH because it's a good token, it's paying good interest rates, whatever, I trust it. And then when I want to sell it, and swap it for Bitcoin on in some centralized exchange, or for another wrapped Bitcoin, or for USDC or something. The markets will be in place to do that.
Super cool.
But
no, market makers make sense. It's a good. The more you limit this, the more you limit the kind of nefarious attack vectors too. So it's nice. Start slow.
That's our you start slow. Yeah. That's more, the slow is plenty fast enough for what we've been doing already. So and we launched we launched the bridge about 2 weeks ago. So we're just getting started. It's kind of a soft launch, so we're on mainnet. It's working. It's proven out with our initial deposits, and we're going to onboard our first merchants and market makers this month, I think, early next month.
Awesome. Yeah. So I guess we're just coming up on the hour. Where can people go to find out more? What can they come do over on the network?
Appreciate it. Yeah. dlc.link is where you can learn everything about our project. There will be a link to our docs page where we can have a bunch more. And, we've got technical specs on there and everything. And as of right now, most users would interface with us by using the DLC BTC token on Arbitrum, soon to be all EVM chains. We've got a Curve pool, we've got a Uniswap pool, more on the way. And probably sometime in the fall, we'll get this token out, which actually is used to incentivize the network and secure it and all that. So it'll be called DLC token.
Awesome. Yeah, no, I'm looking forward to it. All right. Well, this was a blast. No, thank you very much for coming. Yeah. Talk to you later.
Thanks a lot. It was great being here. All right. Nice to see you. Ciao.